You know, there's so many relationships between segments inside of circles that we could talk about them almost forever. So let me share with you some of the really interesting and important relationships that we can actually use to solve real questions that have come up in real math life. The first one comes under the heading of the chord-chord product theorem, which basically says if we have two chords that intersect somewhere inside the circle, then we notice that we have four segments: this line segment, this line segment, this line segment, and this line segment. And what this basically tells us, this theorem, is that if we take the length of AE and multiply it by the length of EB, then what we get is the same thing as taking the length of CE and multiplying it by the length of ED. So basically, visually, if you have two chords that cross inside the circle, this length times that length will equal this length times that length. Again, a beautiful property due to the beauty of the symmetry of the circle. So here's an example. Here we have a circle. We've got two chords crossing. We're told this is 2, this is 3, this is 12, and we don't know what this is. And so our job is to find x, and then find the length of each of the chords. So how would we find x? Well, I know that since they're crossing like this, by the chord product theorem, I have at my disposal the fact that this times this equals this times this. So that means that 3 times x, or 3x, will equal 2 times 12, which is 24. And so if I solve this for x, I just divide both sides by 3, and I see x equals 8. That means that this is 8 right here. What are the length of the chords? Well, this chord's actually pretty easy to find out. This is just 12 plus 2, so that's 14. So we have that BD equals 14. And what's AC? It's going to be 8 plus 11, which is 19. So you can see that this great chord product theorem. Now let's make sure everyone's happy with everything in life. So let's see. If we take the 12 and add the 2, we get a 14. If we take a 3 and add 8, how do we get 19 again? Can you remind me of that? I don't actually remember that. So let's think about that carefully. If this is 8 and this is 3, then the whole thing is 11. So really, I meant to write 11. So AC has a length of 11. So you got it, because this is 3 plus 8. Those of you who think that 3 plus 8 equals 19, you're in my camp of math, which is not a good camp. So let's get into the 8 plus 3 equals 11.